Today, I'm going to talk as an engineer to an engineer that what mindset is required to build the platform, the module, the service you have with the SaaS mindset. So let's go with build a SaaS. Let's see how the journey begins for a typical software engineer, right? There is a product guy who comes and says, hey, here are the use cases. And the use cases are generally about here and near future, which means they're going to talk about 6 months, 3 months, or 9 months roadmap, but largely giving you clarity about 3 to 6 months. And again, for an MVP, they'll be giving you a bunch of use cases which are very restricted. And that's where the journey starts for a software engineer. As we go about the use cases, the moment those things get discussed, the next thing that kicks in are timelines. Now, the moment timelines kicks in, it's always like, when can I get it? Is it tomorrow? Day after tomorrow? Usually that means that you really have less time to think through and come up with how you should build your software. Once the timeline crosses, that's when the real job starts. Now you'll have a team of software engineers, senior software engineers, architects, managers, senior management. This all together creates an experience set that you have. So this experience set is going to define what you're going to build tomorrow, right? What is required when somebody in the team comes forward and says, hey, let's define the platform requirements. And suddenly you will hear this voice somewhere in the room saying, hey, are we over-engineering? Do we really need to think beyond what has been asked? That's the moment of truth, right? And I'm sure each one of you go through it. But let's see what happens as we move along when we ignore these voices, right? Somewhere midway through the journey, the product use cases have changed significantly. What they thought that they're going to build and what customers really want evolves with the time, right? So the use cases changes significantly. You know what? Timelines are still crunched. When they talk about changing things, maybe a bigger things, but time is always going to be a prime factor in deciding what you're going to build. And suddenly you will see in the halfway through, though it's a new product, some amount of tech debt is building, which means that you say, hey, this part I'll take care in the next iteration, right? And when you build a new code, the code is getting fragmented. You're not relooking at your code. You'll let it get fragmented. Obviously, the timelines are important, delivery is important. And hence, the whole thought process about how the code has to be organized is getting a hit. With that, slowly you will see some part of functionality has been discarded because the use cases evolved. And the dead code started growing, which means some amount of dead code, some amount of code is dead in your implementation already. And with time, this is going to grow and become unmentionable. And again, the question comes in, hey, what about the platform ask? And unanimously, you will hear this, it's too late to refactor. And they will continue to say, hey, we'll do it in the next iteration. Or when we do a next major feature, we're going to look at this tech debt and we'll reserve some time. And I'm sure every engineer in their lifetime, they hear the tech debt building again and again, again and again. And you know what? We all blame someone else, but not ourselves. But let's go forward and see how we can take care of it. How do we solve this problem? This is a perennial problem for all of us as an engineer, right? Let's do different. What should be different? When you think of building a service or a module or a project, think of it as a product. Like the way product use cases evolve, your services has to evolve too. So when you build your services, think that it's going to evolve in time, which means whatever code I write should be flexible, modular, and extensible, right? Because you don't know the new use cases is going to kick in. And while you do that, as it evolves, make sure you devote time to keep it lean and clean. We talked about that code building, right? This is where you need to start thinking, hey, when I'm changing, what part has to be shed off and what part has to be kept or needs to be changed. When you're building this, scale is everything. In today's world, on the internet scale, you don't know how many users will ramp up the next day. So you need to be ready when you're building your code or software. You need to be sure that it's going to scale any moment that users want to want it, right? And make sure what you build is easy to onboard and adopt. It shouldn't have like a 10-page document to tell, hey, how to use my service, hey, how to use my product. That's not going to work because adoption is key. You build the whole thing, and if it's not getting adopted, it's a sheer wastage. While you do all this thing, I'm sure you're going to hear, hey, the cost is high. And I want all of you to see the cost is not just money. The cost could also be how long did you take to produce the code or the software? How many engineers that got employed to build that code? How many times do you refactor? That's also a cost. So always look at the value that you're going to provide to your customer, right? And at what performance cost that you're going to provide that value to the customer. When you think of these dimensions while building your software, you will realize that the total cost of ownership is way different than the plain dollars that you end up expensing on your software. And finally, after all these things, you have to plan for the market, right? On time. The competitors are also building this similar software. They're also trying to grab the similar user space, the same market share, and you want to make sure that your go-to-market time is really timely. And that's where the timeline crunch kicks in, and that's where all the compromises start. But you need to be smart about it, and we're going to talk how you look at it. So how do we build a software as a SaaS software, right? The key tenets that everybody should think of, one, which is the most biggest and most talked about, is multi-tenancy. When you start building the smallest module or a smallest service, right at the start of the design, you have to think, hey, am I going to do a deployment either by the customer, by the market, whatever that partitioning that you're thinking of that you're going to make your multi-tenancy, right? Or you're going to handle it in the code that when I'm going to receive that call, and that call, it will provide me those parameters, that value on which I'll be taking a decision that how should my code behave differently. I'll just give a simple example, right? Just look at, some xyz.com/us, and some people who are familiar with REST APIs. They'll say, hey, yeah, this API can be mapped to a deployment, and another /in can be mapped to another deployment. And at places you will see, hey, xyz.com market equal to US, where you're providing our market equal to US as an input to your service. Now, just the reason I'm giving this example, because it's very relevant for Walmart and other retailers, that when you build a software, you always start with some market that you think you're going to create a value, right, for the customers. At that time, it's only for that market. And hence, your use cases, product requirements are going to be around that. But as an engineer, it's your responsibility to understand that, hey, today it can be this market. And market doesn't need to be just a country, right? It could be a very small segment of customers that you're looking at. And you can define that as your micro market, right? When you're building the software, you have to think, hey, today it could be US, tomorrow it could be something else. It could be Canada, it could be India, right? It could be Europe, right? And when you start thinking this, you will know that your code has to be reorganized and thought to very differently, modelized differently, configured differently, so that when the new use cases kick in, you know how to easily extend it with the changing needs of each market, right? With the extension. You also have to make sure that when you do this, you have to give that resource isolation, quota, quality of service for that particular tenant. You cannot afford to affect a set of customers because the other set of customers are taking more resources, right? Because that's the quality of service, that's the SLA that you promise to your customers. So you have to think that when you're building your code, how will you be able to get the resource isolation, right? How will you promise the quality of service that you're promising to your customers so that when it scales up, it maintains its promises? Another thing to watch out for is design for scale, horizontal scale, and be dynamic. which means that today I may be starting with a customer base of say 1,000 users, and everything works perfectly fine. It's performing, it comes back in 100 milliseconds, blah, right? And suddenly, tomorrow, you get 1 million users. Are you ready? I'll give you an example, right? Elon Musk said that, signal is better. And the moment that was done on the Twitter, you would see that suddenly there are like millions of users downloading Signal app and started using it. Now imagine if you haven't built your system, which is horizontal, and suddenly the opportunity that you had to grab this market share is gone. For you, it should be snap of a finger to say, hey, it doesn't matter. 1 million users, fine. 100 million users, fine. I'm just going to spin off more and more resources to be able to support the value that I'm providing to my customer, right? And that's where this whole auto scaler and auto provisioning kicks in, right? Now, when you think of auto scaling or a provisioning, you have to think of utilization performance. I've seen at many places, people throw hardware, but their utilization is below like 20%, right? Make sure you configure your service to be able to start ramping up in time so that when there's a surge kicking in, you are able to handle that service. Or it could be a performance driven. It's okay to be 20% CPU because it's probably IO bound or something else, right? Make sure you understand what you're promising to your customers and accordingly enable the scaling for that particular service. If you have to expand in another market, like I was talking about, right? Say there's the US and then India, you should be able to provision it for that particular region or a country so that the latencies are very low and you are closest to your customers from where they're consuming the service, right? When you do all these things, you want to make sure, because auto scale, it can go up and down, it has to be stateless. Every request, every query that hits your server, if you treat it as stateless, your design is going to be very different, and you will be able to scale horizontally by adding more servers, scale up or scale down based on the need and the traffic that you see. When you do this, and when you're talking about the millions of users, concurrency is the key, right? When you scale up, you want to make sure that simultaneously you are able to handle many more users who are coming there to consume your services for the value that you're providing to them. So your coding has to be very different. Your design has to be very different for that service where you keep everything at the center with concurrency as the mindset. Once you do that, you will see that the hardware that you have actually put underneath for the service is best utilized, right? Now it can be async programming, it can be multi-threaded with statelessness implemented, and there can be a KV store somewhere in the background maintaining the state or state transitions. But what you're not going to compromise is on the concurrency. And many times you'll see that when you bring in all these things, we start talking about corner cases. And you will see a room full of engineers get so passionate about solving for a corner case, instead asking the question, hey, can I compromise on this corner case? How important it is? Is it that 5% I'm going to optimize for, or is it the 95% I'm going to optimize for? When you start thinking this, you will think of an alternate solutions where you don't try to be overly engineering the whole corner case, but you are thinking the right path to take for those use cases and solve it differently. At the end, remember, you are thinking for a value to be provided to the customer and at what cost, the whole TCO that we were talking about, right? Other key tenets that we need to be very, very careful is the design part, right? You have to design for defensive coding. There are many times either we fail silently or we fail without handling it. Handling failures in today's world, especially in the cloud world, it's very, very important. You have to be ready for something that you're dependent on, may just go offline, may not be accessible, may time out, right? But your services should know, hey, how do I react to this situation, to this event? Maybe it's a small time glitch, or a long time glitch. Instead of throwing out this error to the customer, can I do this in a much more graceful manner? Can I offer this customer a something different, some other service while the service is unavailable or not performing? While you do that, and while you see that number of users are increasing, you will see that your services may be degrading if you haven't scaled up the time or maybe some unexpected things are happening. Imagine now you have designed your code or a software where you say, hey, if I monitor my own service performance and I see it's degrading, is there a way that I can change certain features, turn off certain features, because I know that this feature is IO heavy or a CPU heavy or a network heavy, whatever that may be, right? If I turn off this feature, I'll be able to give that quality of service that I promised with, yes, some functionality disabled, right? But I'm still making sure that I'm serving the customer, right? And as I get better for whatever reason, there was an outage or something, right? I monitor it and I say, hey, you know what? Now I can actually turn on my features one by one so that, I can again start serving the value that I have disabled for some time. That's what I'm calling about self-healing. The reason this is important is in the cloud world and with these microservices at play, there's so many services talking to each other. And most of the time, it's very difficult to identify where can I fix what in the shortest time. If you start designing for self-healing, you will realize that you have bought in more time for yourself to fix it later when you get an opportunity to rewrite your own code which didn't perform well or for something else. And you also need to be in control of your own service to say, hey, beyond the point, no matter what, I'll not be able to give that quality of service. So maybe I need to do rate limiting, right? Maybe I need to protect myself from an abuse. All these things has to be thought through during the design phase. And when you start thinking this, you are truly building the product or the module or the service with the product mindset of your own. And this product is an engineering product. Now that you have put on all this thought process, one very, very key factor that needs to be thought through is how do I leverage what's out there, right? Build only what's core to your business. Do not go reinvent the wheel. There's a lot of time I've seen not invented here syndrome. Hey, my use case is very different. Hey, my needs are very different. That particular platform doesn't solve for this versus that. And umpteen number of times I've seen that it's only like 2% of the use cases that's not solving. But what about the 98%? Remember I talked about go to market time? It's so important that you don't end up putting your engineering resources, right, your engineering mindset or your engineering time onto solving, which is already solved somewhere else for the 98% of the use cases, right? So make sure you leverage these SaaS platforms that are available, right, to go ahead in the competition and start focusing on building the product that you actually really want to, with all the tenets that we just talked about. Put that energy there and ensure you use the right software that's already there, the problem that has already been solved. And these platforms will give you elasticity right out of the box, which means that the part that you're designing for yourself and the part that you're going to use, both are elastic. You made your software highly elastic, and you are dependent on a software which is also elastic, which means that when it comes together, when this marriage is going to happen, it's going to be a harmony, right? It's going to be in a harmonious state. As we move forward, there are key aspects today is about security. You have to start adopting secure programming. You have to think about that there are people out there who's going to hack into your system. They're going to either steal your data or going to make your service inoperable. And that can be a chance of a ransom, right? It is a responsibility in the hands of engineers, it is us, to make sure we protect ourselves and our code and our software from such folks who are smart enough, maybe smarter than us, who knows how to exploit the vulnerabilities that are there in the code. I sincerely urge every engineer to spend 20% of the time learning how to do secure program. Once you do that, you're going to have lots of data that you manage, hold, because these days, personalization, using AI, ML, largely using these data to provide even much more valuable service to your customers, right? This data has to be protected. It has to be protected by using rollback access control, right? You want to make sure only the right person who's authorized and authenticated is the only person who can get access to the data. Again, in a time-bound fashion with the right auditability in place. Make sure you use the right key management framework, which is scalable, so that when a service A talks to service B, it is talking on a secure channel and making sure that only service A and service B can actually exchange the data, nobody else can. And obviously, encryption has become by default that everybody should look at. When it's all done, there's a big problem that's awaiting. Yes, you have done the right coding, you have done the right design, you know how to deploy, you know how to securely run your software. But if you're not observing your own software, and one of the things that I was talking about, right, gracefully degrading your service, right? If you're not observing your own service, right, you will not be able to take action. You'll not be able to react to that state of the service, the quality of service timely. So this is the must-have, no matter how small the code is. You have to always remember observability is must-have as the first thing to do. And I iterate instrument. The more you instrument your servers, the more you are able to observe it, the more you are able to measure it, the better you react. The whole point of instrumenting and observing is that when your service is affected, you need to know exactly which part of your service or set of services have gone off or degrading. And once you identify that, only then you'll be able to react to it faster and recover faster. One of the biggest things that people look at is, hey, it was outage, right? How quickly you bounced back, how quickly you recovered from the offering that you had for a customer. That shows the quality of the software, the quality of the company, the quality of the product that has been built by this set of engineers. So these are my key tenets when I look at, when the software is getting built, and I push engineers and myself to make sure that not to cut corners and build the software that has been entrusted by our product guys, by our business, to go out in the market and beat the competition. With that, I want to just tell each engineer to introspect and think, is it the responsibility of a business or a product or a management, or is it your responsibility? You are the people that are being trusted by the product and engineering management and the business and your customers finally to provide that value. And none other can provide that unless you stand up and say, hey, I am building my service as a product, and these standards are non-compromisable, and I will take this responsibility to build it in the right way and serve my customers with the best quality of service that I have promised to serve, no matter when they come up to my service to consume the information that they're coming from. Thank you, guys. That's all I had to say for today.